Hello, Angular Camp. Good after food to everybody. Actually, it's after food. Before we begin, I want to wake up. So let's have some light on the audience. I think the light man is gone. While he's waking up, I will bring my. Can we have light on the audience? Perfect. If anybody wants to still sleep, I found this in my luggage, so you can grab it from here. So I think we'll begin with a nice audience selfie. Yeah, please make it light so we can take a nice selfie. Otherwise, it won't show up. Oh, I need to switch to the camera. So you need to be super happy for this selfie to succeed. So yeah. Woohoo! It will be on Twitter or something. I don't know. You'll figure it out. Before we start talking, the talk, just one note. There is no slides. Now we can begin. So a few words about myself. My name is Uri. I am a Google developer expert for web technologies and Firebase. You can see my photo over there from San Francisco. Apart from being a Google developer expert and working with the web, I also have an hobby which turned into more and more professional stuff of doing stuff with electronics and robotics. If you have anybody heard the term maker, like making things? So Internet of Things and all of that, and it's going to be a part of our talk today. So technology aside, what else do I do in life? I dance salsa. Any salsa dancers in the audience? Yeah, I see there are quite a few, so tomorrow, during the Angular Camp, we may have a salsa session if people want. And then, other than the salsa, I traveled to Peru a few years ago, and I got a pan flute, which I started playing. So I brought it today with me, so I can play you one of your favorite tunes. Let's see who recognizes this one. Yeah, Super Mario, thank you. And last but not least, I work for a company called BlackBerry. Yes, they still exist. And with that, I would like to begin the talk, but not before we have a small survey. I'm really curious to know when will Angular 2 come out, and I will try to crowdsource the question. So who thinks Angular 2 is coming out this year? Perfect. Who is asleep? OK, perfect. So everybody thinks it will come out this year. Thank you. Today, we are going to talk about a project I did a few weeks ago. I'm still working on it, an experimental project. We have heard today from Wasim about Angular Universal. We learned about native script and like getting Angular to run inside a server or on a mobile app. And I wanted to see if we could take Angular even farther, push the limits, run it on new platforms, run it on physical hardware. And this is how Angular 2 IoT was born. Before I'm going to show you what Angular 2 IoT is all about and how it works, let's begin with a simple game. So there is this game from the 80s, I think, called Simon, where you had a few colors, and they lighted in a sequence, and you just had to repeat the sequence of lights. And it got longer and longer and more challenging as you went farther. Anybody knows this game? OK, perfect. So I decided to take modern step in the modern way and build it with Angular 2, of course. And here is Angular 2 Simon. It's the old Simon game we all know with the annoying sounds running inside a browser. The game itself is very simple. It says play. I choose a color. Just shout a name. Green. OK, it doesn't matter. It will play the game anyway. And now I have to repeat a sequence so you can hear it. Etc., etc. And David, I hope you practiced at home because you are going to play it soon. So be ready. I'm not sure if any of you have Bluetooth enabled on their phone and are lucky today. If you do, the address of this game is also advertised here using a protocol called the physical web. I might talk about it tomorrow or the day after in Angular Camp. It's not for today. But if you enable Bluetooth and you have Chrome and you are lucky, you may find it in your iOS notification center or in your Android notifications. I guess a few of you will find it during the talks, probably in the first lines. I will ask about it later. But for now, let's have a look at the architecture of this game. Not very complicated. We are going to start from the main HTML file, from the main app component. So it's a component. And it includes a lot of CSS. Now, CSS and material design is Maxim thing, so I won't get into that. The template is not really interesting. The only interesting part here is that I'm going to make the font larger. I think it's control equals, OK. And the only interesting part here is this. The only thing that this HTML does, apart from this nice bar, is include a component called Simon Game. Now, Simon Game is the smart component in this game. We are going to look into it right now. It's pretty long. It contains all the logic of the game. We are not going to read everything and understand it. It's open on GitHub, and I will post the link in a few minutes. But what I want you to notice is more like the structure of the game and not the logic. So in terms of the structure, let me stop the scrolling so you can focus on it. In terms of the structure, it's really simple. We have 3 types of component. One of them is Simon Score. Simon Score, the one that I marked now, is simply this display that gets a number and displays it retro style. The other one is Simon Segment. Simon Segment is simply one of those colorful buttons that can also light with a color, fill themselves with a color. And Simon Score has an input called score, and at the same time, the Simon Segment has its color, and then it has 2 properties. It has a click property, a click event, which is emitted whenever I press a button. By the way, I'm going to fail the game now. Let's see how it goes. Yeah. So whenever I click the button, this click event is emitted. And there is also a state attribute which determines whether the button will be full or empty. And that's how the Simon Game component interacts with the users through these buttons and this Simon Score component. So we have Simon Score, Simon Segment, and the last one is not really important, but it's here, so I will mention it. Simon Blink. All it does, it brings back, do you remember in the days of Netscape, we had a blink element? So it brings it back from the past for the click any color to start. So We are not going to look at the game logic at all. It's not interesting for the purpose of this talk, but you can do it later on GitHub. To help you with that, I'm going to post the link as we speak on my Twitter. My Twitter is just as my name, URI Shaked, Uri Shaked. So I'm going to tweet. Any special hashtags I should add? No ideas? OK. So you have now the link. You can find it on Twitter. Or if any of you got a notification on their phone, has anybody got a physical web notification with a link? Wow, it reached until the last line. Wow, cool. I think we have like 20 people here. That's great. Google, your technology works. Thanks, God. Yeah, I'm going to tell the Chrome team, and they will be, wow, it works. All right, so we have seen this game. It works inside a web browser, but can we take it to the physical world? Let me introduce to you a small friend of mine. I bet some of you have heard about him. His name is Raspberry Pi. So it has a lot of wires connected. This is a Raspberry Pi. In order to help you see it, I'm going to connect a small webcam to my computer, because I don't think asking everyone to come to the front row will work right now. This Raspberry Pi, have anybody heard of it? Raspberry Pi? Used it? Use it as his main development computer? Really? OK. So this Raspberry Pi is a $35 computer which can run Linux, apparently also Android and the limited version of Windows 10. And it has Wi-Fi and Bluetooth and all of the good stuff. And since it's a computer, it can also run all sorts of code, including, but not limited to, AngularJS, Node.js, and let's check if the webcam works. Camera. Yeah, trusted Windows Store. Oh, it works, perfect. Now, oh, it even focuses. So, yeah, so this is the Raspberry Pi. And it's connected with a pile of wires to a set of LEDs and buttons with different colors. I guess you can see the similarity between the setup that I have here and this setup. Same colors, same number. And what we are going to do now is, give it some power, so it should boot in about a minute, and we are going to connect to it and try our luck running the same game on the Raspberry Pi. So we can play it with physical hardware and not just with inside a web browser. Let me get it a little better angle. Let's do it like that. OK, perfect. Very perfect. It will take it a few moments to come up. I'm going to connect to it using SSH, like we always do with Linux. Let's see if it's up already. And while it's doing it, I'll take a sip of water. Not connected yet. Time to start praying to the gods of live demos. Please work. Let's try to open another window. Is the tethering set up? Maybe it's shy. Are you shy? No? It's OK? Are you OK with the audience? Let's try it again. Meanwhile, let's make sure that I'm connected to the right. Oh, I'm connected to Angular Camp. That's why. I need to connect to my phone's Wi-Fi. So Angular Camp, cheers. The Wi-Fi works great. Thank you. It ruined my demo. Thanks. Now it should connect. Yeah, connected. Thank you, live gods of live demos. So now I'm inside my Raspberry Pi. And I'm going to the directories project. Let's make the font larger so you can even see what I'm typing. And I'm going to run just npm. It's Linux computer. I can run npm. It will just watch the code. Oh, it's IoT : watch. It's going to just watch the code and compile it whenever I change it. Npm run. And while doing this, I will, OK, it's watch IoT. Now it should work. While I'm doing it, let's open another terminal. And in this terminal, I'm going to start the game. So let's start it. And as you can see, it's running. And as you can see in the live demo, it's still trying to start the game. I think it's compiling or something. It's slow. After all, what can you expect from a $35 computer? OK, it's running. And as you can see on the screen, nothing happens. Unlike the web app, I haven't shown you, but it has a nice feature. When you start a game, it starts by flashing the colors, like inviting you to play. So we run the code, and nothing happened. Why is that? I think I know. I think we don't have a web browser here to render the HTML that we create in our components. And apparently, if you look inside those components we spoke about, like the Simon segment one, which displays each of the buttons, we'll see just an HTML button element and a couple of styles. And that's obviously not going to do anything here. And same goes for the Simon score. It's, oh, yeah, right. It's just HTML and a couple of style sheets to display these retro numbers. So obviously, it's not going to do anything. And here comes the magic sauce of Angular 2 IoT. So we are going to the project directory again in another terminal. So we have one terminal watching, one terminal running, and now we are going to edit it on the third terminal. And we are going to go into the Simon segment file. So to remind you, this is the file that renders each of those buttons. And we are going to tell it, instead of just rendering it as HTML inside a browser, we are also going to ask it to render the state of the button to an actual LED that is connected to the Raspberry Pi. So the first thing we need to do is to tell it which pin number the LED is connected to. As you have probably seen on the Raspberry Pi, it has this place with all those pins, and each one has a number. Fortunately, we don't have to guess the pin numbers because I prepared the list of them in advance inside the Simon segment class. So we are just going to consult this object and take the pin number according to the color. So we are going to write pin equals LEDs color. And we also need to set the state of the LED, whether it's on or off. So we are going to say state equals state, just like we use with the HTML button. where it says class.active depends on state. So here we just toggle the state of the LED. And what I'm saving, hopefully it will work, and compile the code, and we will be able to see like the LEDs flashing real fast. It's still like reloading and stuff, or it doesn't work. Let's wait and see. Yeah, it worked. We got a first. Thank you. We got a first component moved from the world of web browser to the world of the Raspberry Pi. We are going to do very much the same with the buttons. So the LEDs are used for the output. We are going to use another directive for the input. Any guesses what name it will be called? What's the name of that directive? Yeah, IoT button. So it's an IoT button, and it also has a pin, and we do the same. We use the buttons map to find the pin number, and then we say, whenever this button is clicked, we simply emit a click event. As you can see, this really resembles the way it works with the web version. So on the web version, we have a button, and here we have an IoT button, and both emit the same click event. And if you think of it, the buttons inside web were modeled after physical buttons. So we are just going back to the sources. So I'm going to save. It will take it. It will ignore my requests. Is it like disconnected? Did it connect to the Wi-Fi again? I think it's OK. Oh, OK, perfect. It's restarting. And it should restart in a moment and run the lights play. And now, since I also wired the button, I will press the green button, as you suggested before, to start a game. It doesn't really matter which button do I press. And if everything is done right, we'll be able to start playing the game. What color was that? I missed that? Yellow. So we got a game working. Actually, thank you. Actually, all that we had to do is simply we reused the same code, the same logic for the game. We simply had to replace the top layer components, those dumb components we just interact with the user, with real physical components, and now we can play the same game inside in the physical world or in the browser. We have both options now. A few of you may have noticed that this game has still one feature missing. So 2 features missing. Sound, yeah, right, and score, right. Luckily, I got my backpack here, and I think I have a solution for that. So yeah, I found it. A 7-segment display, like the one we used on the game. I'm going to wire it into the circuit. Hopefully, I won't burn it. Let's see. I think it goes this way. And then this one and that one. Oh, wow. It says hola, so it speaks Spanish. Right. Thank you. So now, once I connected the display, we still need like to connect it with the actual game. So so far, all of the changes we have done were related to the Simon segment component, to this one. And now we want to change the second one, the Simon score component, the one that displays the score. And we are just simply going to edit the other file, the Simon score component. And right now it has code for displaying it on the web. And we are going to use another directive from Angular 2 IoT, IoT 7 segment. And we simply need to assign it a value, which will be the score that we have. So you can see here below that we display the score by taking the score variable, which contains the number, and then padding it with zeros. We have a function down below called zeropad that simply, it's a function inside our controller, the only one, simply takes a value and adds zeros until it's fat, like the fat arrows from the talk before. So we are going to take the score and zeropad them, just like we do on the web, and assign it to the value of the IoT 7 segment. Copy paste. Yeah. And let's save this. Yeah, I did not do something right. Why did I not do it right? I misspelled what? Right. Good catch. 5xi segment. Perfect. So now, will it compile? Yeah, I got a big error. It didn't compile. And it starts the Simon game, and I think we missed that. So you know what? Let's start it again. And now, when it starts, it actually did this when we missed it. It switches the display, and it says play, just like the web version. And I want to invite David, but not now. So you can take another breath. You will be invited in a moment. So now I can start a game and play it, and I can even see my score. I think it was yellow. Yeah, and the camera doesn't like the amount of light, so it's a little bit hard to see the numbers, but what does it say? OK, so you know how to read numbers. Perfect. Thank you. So last but not least, we have one component still missing, and that is the sound, as you guessed correctly before. I'm going to connect this small speaker to the Raspberry Pi. Hopefully, it will be loud enough for you to hear the sounds. Gosh, I need better nails for that. Yeah. OK, so one speaker goes into the Raspberry Pi sound port. Fortunately, did I say anything funny? Oh, one speaker. Got it. OK, so now we also have a speaker, and fortunately, this time we don't need to do any code changes because I did them ahead of time, but we'll see the code in a moment. Let's first hear it working. So anybody remembers the sequence that led us to this number 3? No? Yellow, red, green? I will take that. OK. You're smart. Wow. Applause to you. You remember it. That's awesome. I didn't. And have you heard the sound? So let's fail. It's funnier. So we failed the game, but we succeeded in building our 3D physical version of the Simon game. And hopefully, this camera will focus at some point. Can you focus? Yeah, it is always distracted by girls. All right. So as I promised to you, we'll have a look at a small trick that we use to make the sound work both on the Raspberry Pi and on the web. Any guesses how the sound works on the web? Web audio, right. That's correct. So in this project, we use TypeScript, and we have just learned about TypeScript interfaces. So we have a nice interface here called analog synth. And this interface has two methods: playTone, which gets a frequency and number of milliseconds to play that frequency, and playSound. So it can either play a tone given a frequency, or it can play an MP3 file given a path of that file. Now, as you already guessed right, we have the web implementation of this interface called Web Analog Synth, of course, which uses the Web Audio API. So it creates an audio context, and then this playTone is implemented using the Web Audio API, and play sounds using the audio element of the web. And we actually use two features that exist inside web browsers, but they do not exist inside Node, to play files, to play sounds. I really hoped that we will have a Node module that mimics this, that I can require Web Audio API polyfill, and I could play sounds, and this would also work on the physical device. Unfortunately, it wasn't that easy. I had to resort to use command line tools on Linux to play the sounds. So the implementation on the Raspberry Pi is different. So we have another class called Linux Analog Synth, which implements the same interface using Linux command line tools, using play and mpeg 1 to 3. The details are not important. What is important is that we have one interface and two classes that implement those interfaces. One class for the web and one class for the physical device. Does this remind you something from the morning talk of Wasim? Yeah, OK, perfect. So I can go home. Yeah, so it's like we had with Angular Universal. One implementation for the client and one for the server. We do here the same, one for the browser and another implementation for the physical device. And actually, Angular 2 IoT was written on top of Angular Universal. So I'd like to thank my friend Wasim and Jeff and Patrick for their Angular Universal project. Guys, you are amazing. Thank you. So the last few minutes of the talk, I want to show you the entry point for the web version and for the IoT version, just the dependency injection trick that we used here. So, OK, I will master this. So this is the web entry point. We can see that we used Angular dependency injection in order to create the analog synth interface and bind it to the web analog synth. So in the web implementation, we bind it to one class. And then in the IoT implementation, which is here, it's a little bit more complicated because it has to do some more setup. But we can see that it binds the analog synth interface to the Linux analog synth. And then inside our app, we simply have to inject analog synth and call the methods of the interface. So let's go into the Simon game, which implements the game logic. And we can see inside the constructor that we have a synth property using private. So Chris, when I told you that I was using this feature, I wasn't lying. Here is the proof. And it injects analog synth. And in runtime, it will inject either the web or the Linux implementation, depending on which platform we are running. This is one of the, in my opinion, one of the more powerful features of Angular 2. that exist in dependency injection. You can read, there is a great article about dependency injection in Angular 2 in Thortram blog. They wrote about it, Pascal Precht, if you know him, wrote about it a few months ago. So that's for the code. Some of you may have noticed that inside the code there was a reference to some online data real-time backend service. Firebase, yeah. So many people ask me, okay, so I can run JavaScript, Angular on the Raspberry Pi. Why should I do it? Two reasons. One of them, I can prototype on the web, and then when I'm ready, I can deploy the version to the Raspberry Pi. So when the game starts, do you remember that we had those lights that go this way? This feature did not exist 3 hours ago. You can see here it's not even committed in the repo. I just added it like just a moment before lunch. And the only thing I could do it with such a short notice is I was prototyping it on my laptop, and then I copied over the function to the Raspberry Pi. So this is really powerful. I can update the game and work on the logic without needing the actual hardware. I actually built myself an emulator. This is one way to look on the web interface of this game. So you can write one code base, debug it using Chrome developer tools and all the goodies that we have inside a browser, and when you are ready, you can deploy it to a physical device. So that's one big advantage of using this method. The second one is that we can use the entire ecosystem that is offered to us by NPM and the Angular community. And I actually connected this game to Firebase and presented a little bit more polished version of it on ngconf. You can see it here. Like this is what I built for ngconf, and this is some random participant playing in ngconf last month. And the game itself is nice, but it becomes really interesting when we add some kind of social ability to it, like competition or something like that. And for that, I asked Maxim, who gave the material design talk this morning, to build us a dashboard using Angular Material 3.0. So this dashboard is actually connected to Firebase. Before we will see it, I will just show you what the data looks like in Firebase. So whenever I start playing, I can see that the variables inside the Firebase updates. I failed. OK, so this will be one last minute. Thank you for letting me know. And let's see what it looks like on the Angular 2 dashboard that Maxim builds for us. So David, come and play so we can end the talk. Okay, let's see how far does it go. So just choose one of the buttons and start the game. Focus on the game, not on the audience. It doesn't matter which one you choose.
I see yellow. I think that they want yellow. So.
OK. Just yellow again. Repeat it. It's good.
What? OK, I should fail because we are...
No problem. Actually, the sound failed. Yeah, you did it. Thank you, man.
Thank you.
So let me just say a final sentence. So yeah, what I want you to take from this talk is Angular 2 was designed initially for the web. We took it to the server. We took it to Universal, to native script. And I want you, the community, and us, actually, to keep experimenting and see where else we can take Angular 2. So let's continue making this awesome.